Welcome to video number 3 of this tutorial series, Scheme Input Sheets. The scheme sheets are where you enter the material data for your project. In order to use this page, the material quantities, element type, and outline material specifications must be known. These can be taken from hand calculations or digital models if available. So as you can see here, the scheme sheet is split into two sections. The top half of the sheet contains the material data table for the scheme. This is where the material data for a given scheme is inputted and the calculated embodied carbon values for each stage are outputted. Below this, there are several charts and infographics giving an overview of different aspects of the given scheme. These can be used as a way to quickly identify how the scheme is performing with regard to embodied carbon. The cells in the table follow a color code. Light grey cells are input cells where you can enter data. Dark grey cells are locked cells where you cannot enter data, and light green cells show the output, the calculation results. Red cells indicate that an error has occurred in the calculation. This will usually happen when the material specification or type is changed so that it no longer matches the relevant material. So for example, the first line here is a concrete element. If I change that concrete material to timber, the tool will flag in red that the material type and material specification no longer align with the overall material for that entry. So if I then change this back to concrete, the red goes away because it's the correct material specification again. So if we go through quickly working through a new scheme, if we flick here, we can go up here and we can name the name of our scheme. So in this case, RC concrete scheme. That automatically updates the name of the sheet and will determine what it's shown as on the comparison page. So once the name has been entered, you can start entering material data into the table. In this example, I want to add 100 cubic meters of C3240 concrete with 50% GGBS, which I've calculated as the volume of concrete required for the reinforced concrete beams in my scheme. So to start, I enter concrete in the material column, followed by in situ as the material type, and C3240 with 50% GGBS as the material specification. As the concrete is being used for the beams in the frame, I enter frame in the structural element column. The description column lets me add text to describe the area of the building covered by this row entry. This doesn't affect the calculations in any way, but it's useful to keep track of what the material is being used for. Here, I put superstructure RC beams. To remind myself that the values I put in here are for the beams in the scheme above ground floor. Now I'm ready to put in the material quantity. In this case, I choose to enter it as a volume, as that is how I've calculated my material quantity. However, if I had calculated the quantity as a mass here, I could choose mass and input the value in kilograms in the next column. Here, I'm going to put in 100 cubic meters as the volume of concrete used for the beams. As I'm using reinforced concrete for this example, I can choose the relevant reinforcement rate per cubic meter based on the application of the element. So here I choose general beam, giving me 220 kilograms of steel reinforcement per cubic meter of concrete. The reinforcement list gives default values for general applications. If I'd calculated the reinforcement density for this particular beam, I could enter it in the rebar table on the custom data page and then select from the drop-down. Alternatively, if I'd calculated the mass of reinforcement separately, I can select NA in this row here, and then I can go through on a separate row and enter the reinforcement weight separately. Here I am entering all the information, select frame again. This time I would probably have the reinforcement in mass. So, and I can enter the material quantity. So if I've entered an EPD in the custom data page, this can be selected by choosing custom EPD from the drop down as the material and then selecting the relevant type So say concrete EPD and choosing the EPD from the drop-down list. Here it's just called test EPD, and then I can enter the information as per the example above. But once I've entered all my data, if we just switch back to the first scheme we looked at, I can check the totals for each stage in the table below. Here we go. The global values and then the total values are summarized down here. To the left of this, I can also see the values given in kilograms of embodied carbon per square metre, which can be useful comparing the embodied carbon between different sized projects. So it's worth noting that we summarised by A1 to A5, upfront carbon, and then sequestered carbon separately, and then whole life carbon A to C, but excluding B, and then module D is reported separately. At the bottom of the page, I can view several graphs and infographics displaying data for the scheme. The first graph on the left shows a pie chart giving the element emission breakdown. This is a good way of quickly identifying areas of the structure that are responsible for large proportions of embodied carbon. In this case, I can see a large portion of the carbon is coming from the piling, and I may consider ways to reduce this in my design. Next, in the centre, we have an infographic showing the total embodied carbon given as tangible carbon equivalents. These are a good way of getting an idea of how much carbon is actually being emitted in relation to real-world examples, and gives a bit of perspective on the impact we can have as engineers. And then below this, we can see an overview of the scores, REBA and LETI targets for the chosen typology as entered on the project input sheet. Here we can see that this particular scheme is missing the scores and REBA targets, and the LETI target does not apply. To the right of this, there is a scores rating for the scheme. This is provided as a graphic, similar to one you might see on electronics such as a fridge or a dryer. This is meant to give a general rating for how carbon efficient the scheme is based on embodied carbon per square metre. Once all the scheme data has been entered, you can move on to the comparisons page for an overview of all your schemes.